Greetings, geometry students. I appreciate you finding time to get your notes taken care of. Today, as the title screen suggests, we are looking at some further properties on parallelograms. So please write the title down, More on Parallelogram Properties. And our objective for the day is the student will discover more advanced properties involving parallelograms. As always, press pause anytime you need more time to copy something down. Hit play when you're ready to move on, and you can rewind if you need to, stuff like that. So let's get to it. Okay, as we looked at last time, we were discussing the basic properties that certain types of quadrilaterals have. And we saw that there were a lot of different properties, side lengths being parallel or not, side lengths being congruent or not, diagonals being congruent, diagonals being perpendicular, stuff like that. Okay, but some of these shapes that we saw had several properties going on at once, particularly the parallelograms. Okay. However, when we are looking at a problem, looking at a diagram on a test or a worksheet or whatever, okay, it is unlikely that we are going to find all of the listed properties in that particular shape, particularly parallelograms. They've got a lot of properties that go along with them. What if we cannot find all of the listed properties about that shape? Does it mean that it is no longer that kind of shape? Do we still have to search for more information before we can call it that shape? Now, those are important questions, and that's actually what we're going to be looking at today, trying to figure out how much information it actually takes before we can call a shape that particular shape. Okay, now we said that quadrilateral, which is a four-sided polygon, would become a parallelogram if it had both sets of opposite sides parallel. That was the definition that we copied down about parallelograms. You probably learned that back in junior high. But we also saw yesterday that when you have that quadrilateral that's got both sets of opposite sides parallel, it also caused both sets of opposite sides to be congruent, both sets of opposite angles to be congruent, and the diagonals to bisect each other. Okay, so all of that is review information from yesterday when we were talking about the parallelograms. But what if we run into a figure that is simply like this? We have a four-sided figure. It is a quadrilateral. We have both sets of opposite angles congruent. Okay, very easy to see that stuff. It is marked in the picture. Clearly, these are properties, okay, being a quadrilateral and having both sets of opposite angles congruent, these are properties of a parallelogram. But we do not have the other information about a parallelogram. We don't know if both sets of opposite sides are parallel. We don't know if both sides of opposite sides, or both sets of opposite sides are congruent. We don't know if the diagonals bisect each other. But we have one property and we're missing the other three. Is that good enough to say that, yes, that is a parallelogram? And the answer to that question is yes. Okay, so basically what we are about to arrive at is if you discover any property of a parallelogram in a quadrilateral, then that means your figure is a parallelogram and all of the properties of a parallelogram do apply. Now you'll notice in that statement, the parentheses, it says at least. The figure is at least a parallelogram and all of the properties apply. Why do we say it's at least a parallelogram? Well, because the shape still might be a rectangle. It still might be a rhombus. We would need more information to go down the rectangle or the rhombus road, but our figure is at least a parallelogram and all of those properties are going to apply. By the same line of thinking, we are going to be able to state that if you discover any property of a rectangle in a parallelogram, now we're talking about the specific properties of a rectangle, like it's equiangular or the diagonals are congruent. Okay, if you discover any of those properties of a rectangle in your parallelogram, then the figure is a rectangle and all of those properties apply. Now, once again, we're saying it is at least a rectangle because it may still yet be a square, but we would need more information to decide that it is a square. And along the same lines, if you discover any property of a rhombus, meaning your diagonals are perpendicular or they're equilateral, stuff like that. Sorry, I got my brain stuck for a second. If you discover any property of a rhombus in your parallelogram, then the figure is a rhombus and all of the properties apply. And once again, we're saying at least is at least a rhombus because once again, it may still yet be a square, but we would need more information to decide that it's a square. Okay, moving on. Now there's actually some extra stuff that we can look for when it comes to parallelograms. There's an extra property, and this one's kind of an oddball, so I saved it for today rather than giving it to you yesterday. So one additional thing we can look for in a parallelogram. If you are able to show that you have one set of sides that is both parallel and congruent at the same time, then that quadrilateral is actually a parallelogram. Okay? So one set of opposite sides, both parallel and congruent, then the quadrilateral is a parallelogram. Press pause if you need more time. There is another property that we can look for on rectangles as well. Okay, so one additional thing we can look for in a rectangle. Okay, and we're assuming that we have a parallelogram, but we said our parallelogram might still be a rectangle if we can find any of the properties of a rectangle. Well, here's another property. If you can find any one interior angle that is a right angle, then that parallelogram is actually a rectangle. Okay. Now in a rectangle, we know that all of the angles are going to be right angles, but this is saying if you can find just one of the angles being a right angle, that's going to make it a rectangle. Press pause if you need more time. And there's also one additional property that we can look for on a rhombus. Okay, so we've already decided for whatever reason that we do have a parallelogram, but we said it's at least a parallelogram. It might still be a rhombus. Okay, so we're going to look and see if we're equilateral. We're going to look and see if our diagonals are perpendicular to each other, and we're also going to watch out for this. If you can find any two consecutive sides that are congruent in a parallelogram, then that parallelogram is a rhombus. Do not get this one confused with the rule on the kite. Okay, that consecutive word tends to make people start thinking about kites, but remember, kites are not parallelograms. Kites do not have any sets of sides parallel to each other. This one is a parallelogram. It has two sets of opposite sides parallel, but in addition, there's two sides in a row that are congruent. That is going to force your parallelogram to be a rhombus. Okay, so moving on, we're going to look at some examples. Okay, you probably need to press pause to get this copied down. There's a lot of information in this picture here. And we're going to answer a handful of questions about this picture here in a moment. So press pause if you need some time to jot this diagram down. Okay, first things first. Before we can start answering any questions about any of the math going on inside of this figure, we better know what type of a figure it is. Now, some people would say it's definitely not a rectangle or it's definitely not a square because it's not standing up straight. But keep in mind, in geometry, you cannot go by what the figure looks like. We need to focus more on the properties and the math and stuff like that. So as a result, every drawing you see today on my notes is going to be identical. They're all going to look like this. That doesn't mean they're all the same shape. But let's see what we have here. Okay, in this figure, we see that we have some tick marks on the diagonals, and we can see that our diagonals are bisecting each other. Okay, well, looking back, what type of a shape has diagonals that bisect each other? Well, that would be a parallelogram. So this figure is at least a parallelogram. But let's keep checking. Maybe it's a rectangle. Okay, so let's see if we can find any of the properties of a rectangle. A rectangle would want its angles, or at least one of the interior angles, to be a right angle. Well, I don't see that anywhere. A rectangle would want its diagonals to be congruent. Well, we know that the pieces are congruent, but we don't know that the overall diagonals are congruent, so I don't see that. Okay, and of course a rectangle would want to be equiangular. I can't see that. I don't see any of the information about a rectangle in there. But what about a rhombus? Okay, what's a rhombus going to want? Well, first and foremost, a rhombus is going to want to be equilateral. Is this figure equilateral? Oh, pretty clear to see it is not equilateral because we have two side lengths that are marked on there, 17 and 25. Those are not the same measurement, so it's not equilateral, it's not equiangular. So parallelogram is really all that we can call this figure. Now, based upon the fact that we now have it classified as a parallelogram, let's see if we can identify some of the measurements that are going on inside of this parallelogram. The first measurement that we're asked about is the length from Q to R. Well, that one was pretty simple. It's marked in the picture. The length from Q to R. We can't ask for a question really any easier than that, so it would be 17. How about the measure of angle SRQ? Well, let's see. Where is SRQ? From S to R to Q. So this is the measure of angle SRQ. Okay, now we can see that part of that angle is 35 degrees. I wonder what's going on with the other part of that angle. Okay, well, one of the things that we know about a parallelogram is that the opposite angles are congruent. So whatever is going on with angle SRQ right there should be the same thing going on with angle QPS over there. Okay, so we have 35 degrees on our angle that we do know. And at the other angle, we have 23 degrees that we do know. Okay, now if we apply a little bit of common sense here, what is actually missing down here at the angle near vertex R? Okay, well, it's that 23 degrees. That 23 degrees that we can see at the other angle is not being represented down here at this angle. And similarly, what's missing up there at near vertex P? That 35 degrees is missing. Okay, so if we put those guys together, we should be able to figure out a measurement. The 35 degrees, okay, near vertex R, and now the 23 degrees, the other part near vertex R, if we put those together, we see that we have an angle measurement of 58 degrees. The measure of angle SRQ is 58 degrees. Okay, how about the measure of angle PSR? Well, PSR, it's over here. Okay, so it's that guy. And we don't have any information about him at all. However, we don't have any information about this one either. So we can't say the opposite angles in a parallelogram are congruent. So we can't transfer the information from one side of the parallelogram to the other. Okay, so let's stop and see if we can't figure out a different way of going about this. Let me clean the diagram up a little bit. This figure is a parallelogram. Okay, parallelogram. So we know for a fact that we have parallel lines. So if we went along the idea of we have parallel lines, then we have a transversal making contact with both of those parallel lines. If that is the case, then what type of angles are this guy and this guy right there? Okay, they are on the same side of the transversal. They are on the interior between the two parallel lines. These guys are same side interior angles. And the rule for same side interior angles is that they are supposed to be supplementary when the lines are parallel. Well, we already know that this angle right there is 58 degrees. So the question becomes the 58 degrees that we do know plus angle PSR that we do not know are supposed to add together to equal 180 degrees. Okay, so if we solve for our unknown angle, subtract 58 over to the right side, then our angle measurement is 122 degrees. Okay, got to keep your eyes open. A lot of the rules that we talked about back in the day, they're going to start to keep coming back on us. Here's another example. Let's see if we can't get this one done real quick. Okay, got the diagram there. Press pause if you need some time to copy that thing down, and we're going to proceed along the same lines as we did on the last example. First off, before we can figure out what properties mean what, we have to know what type of a shape we are looking at. Okay, well, looking at the shape, I see one set of parallel lines. Okay, so it might be a trapezoid. Okay, I don't see any other information as far as things like a rhombus. Okay, the sides want or all of the sides wanting to be equilateral. I don't see any angle information. That's going to make rectangle difficult. Okay, but those two sides that are parallel, they're not only parallel. What else are they? Well, they're congruent. Okay, well, we have a rule that talks about what happens when you have one set of sides that's parallel and congruent at the same time. And when you have one set of sides parallel and congruent at the same time, that is a parallelogram. Okay, but again, we don't have any further information about rhombus or rectangle, so parallelogram is probably as good as we can get it. Okay, so let's get here, see if we can't figure out what's going on with these measurements. Okay, we have the length from V to X is one of the questions that's being asked. Length from V to X. Well, that one's not too bad. It's coming along the length of the diagonal, and since it is a parallelogram, that means the diagonals have bisected each other. So if this guy up here is 7, then this guy down here is 7. So the length from V to X should be 7 plus 7, which is 14. No big deal there. How about the length from Y to Z? Okay, well, the length from Y to Z is here. Okay, and once again, it's a parallelogram. One of the properties of a parallelogram is that the diagonals bisect each other. So if this guy over here is a 6, that's going to force that guy right there to be a 6. That one was pretty easy as well. And we're also asked for the length from W to X. You know, W to X is right there. Okay, well, we have a parallelogram. What do we know about the side lengths in a parallelogram? In a parallelogram, the opposite sides are always congruent. So if this guy up here is 10.3, that is going to force this guy across from him to also be 10.3. As you can see, sometimes the problems move pretty easily, sometimes a little bit tougher. It just depends. Okay, well, the last thing I have is I've got two shapes that I'm going to give you along with some questions. I want you to copy the shapes and respond to the questions. Once again, responding to these questions that I give you in your notes, that is part of your notes. So if you show up tomorrow without these questions answered, then that will be a reason for me to deduct points off of your notes being completed. So copy this shape down. Based upon the properties that are there and the information that is shown, see if you can figure out what type of a shape it is. Based upon that type of a shape, answer the 3 questions that are shown. Press pause if you need more time. I'm about to change the screen to the next diagram. And lastly, there's one more diagram And as I've told you before, when the diagrams get more and more complicated, sometimes you get some external information attached with the figure. We've got a little bit of an example of that. One of the angle measurements provided for you over on the side. But again, copy down the diagram and the information. Figure out what type of a shape all of that means that this is, and then respond to the 3 questions shown. I appreciate you finding time to get your notes done. Press pause if you need more time. The video is about to end here in a moment, and we'll see you in class.